Welcome back. So now you want to distribute your program and it's really so large. You want to reduce the size of it on the disk and for the transfer. So the best practices that we have here, I'm going to let you know about the Windows, Linux and Mac. How would you do that? You have DLL files or your executable programs that you want to send to somebody else. So the very first thing you do is within your program and source, you minimize the unnecessary dependencies. For example, you are utilizing a library, which is image manipulation library, and you are not doing any image manipulation at all. Or you have, for example, an alternative library that you can utilize for your functions, just for resizing a PNG, for example, and you have added the hell of libraries along with it. It won't be necessary. Just cut them off. And this would be specific to your project or your program. You'll have to reduce the size. To reduce the size, you'll have to remove those libraries. Trim the unused code. Of course, go through your code and do not create heavy structures. And even if you have created, do not create a lot of instances within the functions and see your source code and trim them out. Just remove that code which is unused within your program. Do this practice before you go on to the final distribution and compilation of your program. And use of similar data types, choose a smaller data types you can utilize for program. For example, you are getting an age from the user. You do not need to store it in an integer. Maximum human age these days is 100 years, maybe in Japan or in the mountain areas of Pakistan and India. So you don't have to save that data, large data. So utilize the smaller types. Maybe use an unsigned character for storing the human age, which goes beyond 250. Which goes beyond 250. It's 255. So nobody reaches to 255. So store it in character instead of integer. Integer takes 4 bytes. So reduce that in everywhere possible in terms of storage, the program that uses, the memory the program that uses, as well as program's size itself. So now the manual memory management, which actually is a little dangerous. Of course, I have taught you. I have demonstrated you how to allocate and deallocate memory. You can utilize these capabilities instead of defining the whole bunch of long arrays within your program so that you do not have a memory overhead. But again, this practice is really good. If you are expert at allocation and deallocation, you take care of it. You do not leak the memory anywhere. It's fine. So the program size is going to reduce. Static versus dynamic linking. This is something wonderful. We did study how to create DLLs in the common code that we have amongst the applications. And we want to use exactly the same code throughout the applications, multiple applications, or maybe even a single application. And most importantly, once you do that, you create a DLL, you are still able to compile it. You're still able to reduce size of it. You are able to compress it. I'll just demonstrate in a while. Avoid the large libraries, as I said earlier. In here, minimize the unnecessary dependencies. This actually is part of it. Avoid the unnecessary libraries, large libraries. If you have a library, like for example, you're using GTK for UI development, but you are specific to Microsoft Windows, you can utilize Windows specific library, which does not address the cross-platform stuff. It would be smaller and it would have little smaller runtime libraries to avoid adding unnecessary code to your executable. Then we have minimize the string duplication that you usually or most of the developers do. Better is creating some constants in the beginning of the program if the strings are being utilized again and again and again, the same stuff, and concatenate them and utilize those variables or constants which are globally available. that would reduce the size of your executable. And it applies not only to strings, it applies to all of the data structures which are similar, but yet being duplicated again and again. And avoid the redundant data, minimize the duplicate strings and data utilizing shared constants, executable size compression that we have. This is like pretty much the same. So executable compression. Here is where the game changes. We can utilize, there are many program compressors, executable compressors. The best one that is available cross-platform is UPX. It's a ultimate packer for the executables. It does compress the shared libraries, DLL, SO files, executables for Linux, Mac, Windows, etc. Then you have to strip down the debug information. Most of the compilers, when they compile the normal program, except for the TCC doesn't add that. GCC adds that, Microsoft Visual C adds that, Intel C compiler, etc. These compilers, Digital One C compiler, they add this debug information which is utilized at the runtime about the names of the variables and the functions in the code base where exactly the leakage might happen. It would be able to detect it and respond back properly with a proper message that this part of the program is failing. So when you know that your program is 100 perfect enough, you can strip down that information from the executable. You would have in your IDE, for example, we have been using Genie throughout the course, but for creating projects and larger projects, you would be using some better IDE. Genie also supports project management. It does have menus of project management. You can create a new project, add a code base. Your instructions about the compiler would be added there only. You don't need to create batch files that I have been testing with you, showing to you. You can use code blocks. You can use other better choices. You have Visual Studio as well. But if you want to go with this open source and normal quick stuff, which actually I prefer, lightweight applications, it's not necessary that you do the same. You can even use Adobe's Brackets, which is an amazing IDE. I've used it for a while. It's lightweight and it has hell of capabilities, outstanding. So you remove the debug information by using some special the project tools like in MSVC, Microsoft Visual C++, or Visual Studio. You have debug builds as well as release builds. So select the release version. But if you're doing it manually, that I have demonstrated with GCC or TCC, I'll just demonstrate in a while how do you strip that information. Then you have custom build targets. Of course, the minimal version, which actually I did say above. The profile and experiment. Profile the code to identify large section and experiment with optimization. So you use if def and definitions within your program. These are instructions for the compiler to include or not to include your testing part of the program. If it is a test build, of course, you supply the minus capital D and the constant name from the command line, which all C compilers do accept. And if that is available, certain code is inserted or stripped off depending on your need. And then, of course, keep the cross-compatibility, cross-platform compatibility in mind. If you're specific to Microsoft Windows or Linux or Mac, you're creating iOS application, of course, you'll have to not worry about the cross-platform stuff. But if you're creating a desktop application that you think might be useful in the future for other platform users as well, then keep in mind the cross-platform compatibility. Do not strip off a lot of code. For example, we have studied inline codes, inline functions. Those inline functions are actually deflected. They are expanded inline. They add extra code to the executable. Why not? Sometimes you need performance and you do not worry about the size of your project. size of your final executable. Then you can finally use the executable compressors on your program and do not reduce that part which is giving you performance where your program is performance critical. By adhering to these practices, you can effectively reduce the final size of your C program executable, especially on Windows, leading to no more efficient software distribution, leading to more efficient software distribution. Thank you. If you have any question, we're going to do a little testing here. So what we have here are some executables, but we don't have executables. Let's create them. This program is being compiled. Image loader is using GCC. And let's remove this option. I'll explain to you why I removed and why would we add this. Let's compile this program, and our program is compiled perfectly. We have the image loader.exe. Then we have the main program, which is using a TCC, a tiny C compiler, and we are going to compile that as well. Okay, we are done. It's efficient compiler. It's fast. So this program, actually, let's arrange it in a way so that we can see the sizes as well. Okay, fine enough. So do it this way. Bring it here. Okay, you see image loader is 78 KB, 78 kilobytes compiled with GCC. The main.exe is 21 KB, which is compiled using TCC. If we, for example, if we edit this GCC code and add here the command as, that means strip the debug code. We close it, we run it again, and it was 78 KB, but now it's going to be a little different. I think it is compiled just fine. Let's close this and see that your executable size, let me do it again. Let me just zoom out. Close this and let's do it again. Okay, so after stripping the code, the executable size has reduced to 50 KB and now it became 28 kilobytes. Now, it's 28 kilobytes only. Let's bring it here. 28 kilobytes. Now, this was how you strip off the code, strip off the debug information. Now, there is one more way of doing the compression, and we can test that. And here you go. If you have to compress image loader, for example, you use UPX, and you can use maximum compression is 1 to 9. So you can use 1 to 9 different levels of compression. I use maximum. I say image loader .exe, and it is compressed to from 28 kilobytes to 14 kilobytes. Yet, if you want to distribute it, you right click and you zip the file and send it over. And this is still going to be reduced to 12 KB. So we came from 78 kilobytes to 12 kilobytes. This is how you do it. And let's see this example, our main program that we had an example of when we were doing GUI stuff. We had this small example of Windows GUI, a graphical user interface. It's working just perfect. Let's compress this program, which actually is 21 kilobytes. Let's compress this program, main.exe. And after compressing this program, we come to know this is just 8 kilobytes. And when you compress it using the zip as well to distribute it to your client, you have only 7 kilobytes. It's showing 7 kilobytes, but practically it's 6.17 kilobytes or 6.2 to be rough. And just to make sure if this executable after compressed is working or not working. So we'll just test it. We'll double click and run it. We'll see that everything is working 100%. There is no difference in the program and no speed penalty that we had. Everything is working just fine. Now, one more thing you need to keep in mind, when you compress DLL files, using the same UPX program, you might encounter some problems I did try on so many different shared libraries and programs. The programs did work just perfect. With the shared libraries, some that they have symbols really so strangely bound within it are defined, like the PHP interpreter. For my other course I was doing, the PHP interpreter has the DLL files along. If you compress them, they're not going to work. So whenever you do that and you compress your shared libraries, just make sure run the program first, test it. If it works fine enough, or play with the different options of UPX. And what you can do is you just type UPX and help is going to arrive. You're going to see what are the options that it is providing. And you can utilize them. Compression, it says 1 to 9. And then decompression as well. You can decompress the executables back, or your for more detailed help, for example, you can just type help and you will see a longer help. Platform specific stuff and so much tuning. And you can even choose not to compress the resources, Windows executable resources. If you have RC files, we did work with resources and you know what they are. Thank you very much. This was it so far. If you still have any question, if you did not understand anything, just let me know. I'll explain. Thank you.